Okay, we're going to start this new section called kinetics. Specifically, we're going to be looking at gases and the properties of gases. To begin that discussion, the first thing that we're going to have to do is we need to talk about what is pressure, understand the underlying factors. So, to begin, force can be described as a push or pull on an object. Okay, force is going to be an integral factor in our understanding of pressure. So what I want you to think about is a force could result from, let's say, an object in motion. Okay, let's say we've got a ball, that ball is flying, and that ball, it collides with a wall. So the force is a result of the collision. Okay, if the ball strikes the wall, what the net effect is going to be is if, let's say, this wall is on wheels, it is going to push this object back. Okay, so that is my force. I have one object in motion, and this object is going to cause another object to get pushed or pulled. Now, there are other ways of considering force, but this is the one that works best for our purposes here. The expression for force mathematically is force equals mass of the object times the acceleration of the object. Okay, so the change in speed. Okay, so if this object is moving at a constant acceleration, okay, so if it's moving faster and faster and faster, it's going to have more and more and more force involved in the blow. So the next thing that you need to understand is our definition of pressure. Pressure is a force applied across an area of a surface. Okay, so the thing to bear in mind here is in our previous example where we have the ball that slams into the wall, okay, the force is applied across this surface. Now, if I was only looking at the specific contact area, we could describe the pressure on this area compared to other areas. So the force applied across an area. Another great way of considering this is, let's say you're standing on a scale, and if you're trying to balance just on a single tiptoe, then all of your weight is being pushed down on a very, very, very tiny area, so that's a large amount of pressure. If instead you're flat-footed and you spread your weight out, then there's going to be less pressure even though the force is the same. Okay, so we say that pressure is equal to the force divided by the area. Okay, pressure is the force divided by area. Now, pressure is greater with large forces or smaller areas. The idea here is, again, I want you to consider, let's say I have this area, it is 1 inch by 1 inch. Well, if, let's say I apply a force, we're not going to get really into the units, but let's say I have a 100 unit force that I push down on this 1 inch by 1 inch pad. Okay, that is going to be 100 divided by the 1 square inch. Now, if instead of a 1 inch area, if I did this across a large area, let's say it was 12 inches by 12 inches square, so a much, much larger area, then I would have to take my 100 force units again, but instead of dividing by 1, I would take 100 and divide it by 12. So, same force, but a larger area results in less pressure. Or same force with a smaller area results in a greater pressure. Now, on the other end, if I had my 1 inch by 1 inch square still, instead of doing a force of 100, if I did a force of 500, so an increased force, then my pressure would be 500 over that 1 square inch. So a larger force results in a larger pressure, so higher energy collisions as it pertains to us. Okay, now I'm going to ask that you take a second, work out, so no, I have to do conversions. Sorry. Real quick, there are several common units that express pressure. The first is known as the atmosphere. Okay, so a single atmosphere of pressure is equivalent to 760. These are millimeters of mercury. Millimeters of mercury. This is equivalent to 101.3 kilopascals, which is equivalent to this unit 14.7 psi, or pounds per square inch. And lastly, it is equal to 760 torr. Okay, so that's the Torricelli unit. You'll notice that our millimeters of mercury and our Torricelli units are going to be consistent. For our purposes, they're exactly the same. So, lastly, we need to understand that the pressure of an enclosed gas is caused by the random collisions of the gas molecules on the surface of that container. When we discussed a force and we discussed pressure, the force is, of course, a mass. So our molecules, they have a mass and they are accelerating along. So the energy of their collisions against the surface of the container divided by the surface we're measuring, that is what we have as our pressure. Now we're here at these practice problems. So I'll have you take a second to pause the video, work these out, and then we'll continue on. So firstly, what is the expression for force? So the expression, meaning the equation in general form. Force is equal to mass times acceleration. What is the expression for pressure? Pressure equals force divided by the area that we are discussing here. So force divided by area. Complete the following pressure conversions. So now we have to make our relations from the previous conversion chart. Recall all of these things are equal to each other. So you can look at any one of these and convert from one to the other. Make whatever possible connections are necessary. We end up getting this large star, if you will, of all these possible directional conversions. So 76 millimeters of mercury, 2 atmospheres. We're going to begin with the 76 millimeters of mercury. There are 760 millimeters of mercury in our standard pressure value, and that is equivalent to 1 atmosphere, which gives us 0.10 atmospheres. Now we want 3 atmospheres to kilopascals, so we'll take our 3.00 ATMs. We know that 1 atmosphere is our standard value, which was 101.3 kilopascals. So this is equivalent to 303.9 kilopascals. 825 kPa to millimeters of mercury. So what we have to understand here is that my kilopascals are 101.3 kPa, and my millimeters of mercury are 760. So we're going to take our 825 times 760, and we'll divide that by 101.3. Give me a second and I will work that one out here. Okay, this gives us 6,189, but rounded it will be 6,190 millimeters of mercury. And now my 380 torr to kilopascals, so that is going to be 380 torr. Standard pressure in torr was 760 torr to 101.3 kilopascals. And 380, if you look at it this way first, 380 divided by 760, notice 380 is exactly half of 760. So 380 divided by 760 is 0.5, and 0.5 times 101.3 this gives us 50.65 kilopascals.